Hello everybody. So here we have part 4 of the series on continuous functions. In this video we'll talk about say if you find some statements that are true false in your assignment about continuous functions, then this is the video where I'll talk about how to think about that sort of thing. Okay, so first example, consider this function. Okay, it's a piecewise function. You calculate y by this formula if the x's satisfy this condition, and you calculate y by this formula if the x's satisfy that one. Okay, you can look at this, take it in however you want to, but here's what I want to ask you about it. So as it is, this function is not continuous at 7. All right, so why is that? Well, I mean, what do you get out of this function when x is 7? When 7's an input, what do you get for the output? This is undefined at 7. You know, this formula does not apply for the input 7. It's for only x less than 7, greater than or equal to -2. And this function, or this formula, doesn't apply to x being 7 either. It's just for x greater than 7. So 7 doesn't satisfy either of these, so it's implied there that that function's undefined for 7. There's nothing to do with 7. There's no way to get an answer. Okay? All right, so that's the way that it is when we first look at it. Now, what I'm asking here is, could you alter this function so that it was defined at 7 in a way that it was continuous there? Okay? Now, the way that that statement is given is it says, find the value of the number n such that if f of 7 was n, then the function would be continuous at 7. All right. So let's find that number n. Now, you can answer this however you want to. You definitely, I mean, I wouldn't be surprised if, just depending on who you are, if you could answer that question just by looking at this and thinking about how it worked. You know, if you're good at that sort of thing, if you've got a good imagination, then good for you. It might be easy for you. I think for most people, it might help to look at a graph or some, you know, just something visual, something to attach your thoughts to. So here's the graph of that function. It's defined from x is -2 on to infinity. Here's that first curve right there. What was that one? Root x plus 2. Okay. And then remember, it was undefined at 7, but if I were to put 7 in, it would give me root 9, which is 3. So that means that this curve goes right up to 3, but it does not include that point. And a very important feature about this one is I noticed that this other formula, this line, picks up where that one leaves off at. Okay? It's not defined at 7, as I mentioned, but if I were to put 7 in, 7 minus 4 is 3. So that line picks up exactly where this curve leaves off at. So we get this. We get this graph that's missing one single point. All right, and it's missing one single point because that original function was undefined at 7. Okay, f of 7 was undefined. Now, I think I got the answer. Informally, wouldn't this be continuous at 7 if I filled in that point? So I got my pencil and I just colored it in. Would it be continuous? It'd be continuous then, yeah. Okay, now mathematically, what does that mean? It means that I need, when x is 7, I need y to be 3. Okay, that's a little bit better. Yeah, if that point, 7 for x, 3 for y, if I filled that in, if I included that, this would be continuous. All right, so let's take it a little bit deeper. That's like saying f of 7 is 3, isn't it? That's using function notation. It's like saying if I put 7 in for x, I'll get 3 for y. Yes, okay, if that were the case, that would be including this point right there. Then that one point that's missing would be there, and it would be continuous. All right, so there's my statement about this one. How would we answer that? What's the number n such that if f of 7 was n, then the function will be continuous at 7? Well, n is 3, okay? So there's our answer. N is 3. If f of 7 was 3, then the function would be continuous at 7. All right. Okay, so that, it's probably not that hard to do. But part of what I'm trying to get you to learn here is how to read the information you're given and understand mathematical statements. It's not like the math is extraordinarily difficult. It's mainly conceptual, all right? Now, just because you might see questions asked in different ways in the assignment, I want to talk about an alternate way that this one could be asked. So I might give like this, and I want you to see that if the question was stated this way, it's no different at all. It's exactly the same question. So it's considered the function f of x, where f of x is root x plus 2 if x is between -2 and 7, including -2. F of x is x minus 4 if x is bigger than 7, and f of x is this number n if x is 7. Well, that's like saying if you put 7 in for x, you would get this number n for y. All right, find the value of n such that the function would be continuous at 7. Okay, if the question was asked that way, it would be no different than that very first question that I showed you, and this would be the same answer, right? It's no different. It has the same answer. It might look different, but for right now, I want you to see why this is exactly the same as the first question. Question 1 is the same as question 1.1. If you're not sure about why that is, if it's just not clicking, then that's something that we'll need to talk about, all right? Okay, let's do another example, okay? I'm going to try to cover a little bit of everything that you might see. So I have this one, which I think looks very different than that first one. It says, consider the function f of x is absolute value x minus 4 divided by x minus 4. It happens to be that this function is not continuous at 4. Do you see why that is? Can x be 4? Is 4 in the domain of this function? Is this function defined when x is 4? No, no, and no. If I let x be 4, I'll get 0 over 0. That's undefined. Okay? So as it's given, yes, this function is undefined at 4, but is it true that if f of 4 was 1, then the function would be continuous at 4? Is that true or false? I know that the way this is given, f of 4 is undefined, right? Okay, try to plug it in. You won't get an answer. But if f of 4 was 1, then the function will be continuous at 4. True or false? Okay. Well, I think it might be good to analyze this one first. Okay. I want to think about deep down, like all simplified, what's really happening in this function. Okay. So let's do a little bit of analysis for that. So I'll think about like this. I'll say, let's see, 4 is obviously not in the domain. So notice I made a little table here just to do an experiment. We don't do many experiments in math, but I think this is a good one for you to see, okay? I kind of centered the table on 4, and I made a note here that it's undefined at 4. And then I wanted to see if there's a pattern elsewhere, okay? So I did 1, 2, 3, and below 4, and 5, 6, 7 above it. And then there's a pattern, right? You can verify these numbers yourself. Plug them into that original function, see what you get. If x is 1, y is -1. If x is 3, y is -1. It kind of looks like if I plug in anything less than 4 for x, y will be -1. And if x is 5, y is 1. If x is 7, y is 1. So it looks like I'm seeing a pattern that if I plug in anything bigger than 4 for x, then y will be 1. So I have this hypothesis that f of x really, here's what's really happening in that function. I could reduce this to this, these instructions. F of x is -1 if x is less than 4. F of x is 1 if x is bigger than 4. My hypothesis, what I'm claiming to you right now, is that this is exactly what's going to happen in that. So why not just think about it this way, okay? All right, now, hypothesis, that's kind of a strange word to use in math. It's more appropriate for science. In math, we can prove things definitively. So for me to call this a hypothesis is a little bit sloppy for math. So I'm going to, I'll make something appear here that I think makes this definitive, okay? Okay, so there, I think that makes it definitive. If these numbers are equal, if x is bigger than 4, well, what happens when you divide two equal numbers? Well, you get 1. 7 over 7 is 1. Whatever, 10 over 10 is 1. 17.6 over 17.6 is 1. Okay, I've probably taken it far enough. And they are opposite if x is less than 4, right? Why is that? Well, because if x is less than 4, then both of these are going to be a negative number, okay? And then, but the absolute value of a negative number makes it positive, and so they're opposites. And what happens when you divide two numbers that are opposites? Oh, you get -1. Okay, so this is no longer a hypothesis. This function here works like this, okay? All right, now let's think then about the graph at this point. You don't have to draw the graph if you don't want to, but I think it might help most people. So I'm going to give you an alternate way to think about this, a visual way to think about this. What is this function where y is -1 if x is less than 4 and y is 1 if it's bigger than 4? So let's get the graph next. Okay, and there's the graph. Did I draw the graph correctly? Well, all right, so here, what's this? What information is on this graph? If x is bigger than 4, or that's like over here, then y is continuously 1. And if x is less than 4, that'll be over here, y will be continuously -1. And then see these open circles. That notation on our graph means what? It means that this point right there, x is 4, y is 1, is intentionally left off. It's not there. This is undefined at 4, okay? All right, this one here means that this point where x is 4, y is -1 is also intentionally left off. It's not there either. Why? Well, because, I'm trying to give you a graph of this, which is nothing but a description of this original one. It works exactly the same way. And that original function was undefined at 4, any way you look at it. Okay, so there's the graph. Think about the graph if that will help you. Now, let's go back to the question, or remind ourselves of the question. True or false? If, for that function that I just showed you, if f of 4 was 1, the function would be continuous at 4. Is that true or false? Well, what would this change about that function? Okay? As it is, this function is undefined at 4. Okay? But what would change about it if f of 4 was 1? Well, if f of 4 was 1, wouldn't that include this point right there? Yeah. So there. That's what would change about this or this if f of 4 was 1. But would that make it continuous? So I just filled in this point right there. Did that really change the nature of this being continuous or not? No. It wasn't continuous as it was. This is called a jump discontinuity. But so you add that point in. That doesn't change it. This still is like two disjoint pieces right there. That one's false, isn't it? So what do we say? Our final statement about this. True or false? If f of 4 is 1, then the function would be continuous at 4. That's not true. I showed you the picture. It has a jump discontinuity at 4. So we can say false. If we need to elaborate at all, we can say f of 4 cannot be defined in a way to make the function continuous at 4. It's not just that it was 1. It doesn't matter what that number was. It wouldn't make it continuous, right? No matter where I decide to put a point here at x is 4, it's not going to connect these two pieces into one solid piece. It's not going to make it continuous, okay? So we'll say false for the short answer. If we need to give the long answer, we'll say, well, not only that, but it doesn't matter what f of 4 is. It's not going to become continuous either way, all right? Okay, so let's do one more. Or let's two more. I think I can do like this one and then one that's kind of a corollary to it. So again, consider the function, okay? And here I give you another true-false statement for you to decide on. True or false, the limit as x goes to 3, f of x is 1, and f of x is continuous at 3. Is that true or false? Now, I'm going to show you a lot of ways to think about this. I'm not saying they all have to appeal to you or that any of them have to appeal to you. You can think about this however you want to as long as your reasoning is correct, all right? And I say all that to say that, even though I'm going to explain this, this is a question that you might know the answer instantly to just by looking at it. Again, just depending on how good your imagination is. And I think that's true for every question I've done in this video. If you're looking at it, you're not sure, then here's some things that we can think about. Okay, first, this and right there. I feel like that's something that I should talk a little bit about, just my experience in teaching math, and math sometimes involves logical statements, that I should talk a little bit about that. Sometimes people have trouble with it. Okay, so first thing to tell you about that, an and statement is true if both parts are true. So here's a fairly easy one to think about. This is an and statement. An and statement is made of two individual statements, and the entire statement's true if both individual statements in it are true, such as 10 is even and 10 is divisible by 5. Is it true that 10 is even and divisible by 5? Well, these individually are true, so the and statement made from them is also true. Okay, but as the converse of this, if either part was true, the and statement would be false. Take, for example, this one. 12 is even and 12 is divisible by 5. What if I said 12 is even and divisible by 5? Okay, well, that one's true. This one is not. That makes the entire and statement false. Okay, so that's how and statements work. Okay, that's the short story at least. So here's the analysis that I think would apply to this function. Okay, here's the breakdown for it, where it might be a little bit easier to decide if each of these were individually true. Okay, so I will take our function, and you've seen me simplify things like this before, like I could factor that top, the numerator, and then I could cancel. There's some fine print on that canceling. We'd like to cancel stuff. Every person I've ever seen do math in my history of teaching math loves to cross stuff out. All right, I guess it just comes with a lot of enjoyment to do that. But when you cross these out, you're dividing numbers. You're saying that any number divided by itself is 1, and that 1 is essentially unnecessary to keep track of. But that's not a number. X is a letter. You got to think, the further you go in math, you have to think more hypothetically about what's really happening. That X is a number. Like it could be lots of different numbers. And I can only cancel this if that's not 0 divided by 0. 0 divided by 0 doesn't cancel. What will make that happen? Well, if the X was 3, it would happen. Remember, the X is at the end of the day, it's a number. So I can do this. I can cancel there. The condition on it, the fine print, is that would only apply if X is not 3. So this will reduce to something significantly simpler, just X minus 2, so long as the X isn't 3. Okay? All right. Now, my awareness of this allows me to reduce this function to this much simpler one, this piecewise function. F of x is x minus 2. If x is not 3, again, x cannot be 3 for that reduction for reasons given there. And f of x is undefined if x is 3. Okay, so what would that look like? If you were to see this as a picture, see that complicated looking thing that we started with, what is that really? That is equal to this, and this can be visualized as a line with a point missing, or a line with a hole in it, okay? All right, that's all it is. How did I come to that conclusion? Well, I drew the line x minus 2, which is this line here that has a slope of 1, and it has a y-intercept of negative 2. And my graphs that I draw for you are almost never to scale. They're just for purposes of visualization, okay? But there's that line, and then I needed to leave off the point where x is 3. Where should I put that point? Well, if I could let x be 3, I would get 1. So that point that's missing is 3 for x, 1 for y. Okay, so I think I got it then. Let's go back to that question. Okay, so remember I just showed you what this essentially is. This function that we started with, that this question refers to, is essentially that picture right there. Okay, is it true that the limit as x goes to 3 for f of x is 1? True or false? That is actually true. Okay. So if I say I was just asking you that and I wasn't having an and statement, that would be true. Okay? Yes, as x is close to 3 from either side, that will put the y as close as you want to 1. The closer the x gets to 3, it's going to squeeze the y close to 1 around that point that's missing. Okay? So that's true for sure. But is f of x continuous at 3? Well, no, obviously not. There's a hole in the graph, okay? Maybe we could have seen from the beginning that, well, this is not defined at 3, so something's going on there. It turns out there's a hole in the graph at 3. So our and statement boils down to these two statements, the first of which is true and the second is false. So that entire statement about this function being an and statement is going to be false. Okay. All right, final answer there, false. It is not true that the limit is 1 and the graph is continuous at 3. Okay, so I thought since I took this one as far as I did, I could get a little bit more mileage out of it. So let's do this one, 3.1, all right? So I give you the same function, so nothing's going to change about how you're thinking about it, okay? And if we need to think about what that function is, I can take you back to this. If you don't like the picture, I can take you back to that piecewise function that reduces this original, whatever you want, okay? But here's the question that we're asking about this one. True or false, the limit as x goes to 3 is 1 and f of 3 is undefined. That's true, right? I talked about how it would be true for this one, that the limit as x goes to 3, f of x is 1. If x is close to 3, y will be close to 1, according to this picture. The closer the x is to 3, the closer the y will be to 1, according to this picture, or this formula, or if you made a table, however you think about it. That is true. But also, f of 3 is undefined because there is that hole in the graph, okay? F of 3 is undefined because look at that original formula. Try to put 3 in. It doesn't work. You won't get an answer. You'll get 0 over 0. However you think about it, f of 3 is undefined. So here's an and statement. First part, true. Second part, also true. The entire statement, true. It's an and statement. An and statement will be true if both parts are true. Okay. Now, this I think will cover it for the part of the assignment that involves true-false questions, okay? Not everything in the assignment is in the video, but it's going to be part of one of the questions. On the questions that I did here, I elaborated on a little bit so that I would cover implicitly everything that you see on the assignment. If you have trouble, like always, just ask for help.